All right, this is Algebra 2, Section 8-4. This is multiplying, dividing, and simplifying rational expressions. In this particular section, this particular unit, you are going to need to know factoring and a bunch of other Algebra 1 rules as well. Pretty cold because this is going to get a little on the tricky side. Okay, so we're going to evaluate numbers 1, 3, and 5 into this. So I'm going to do this first one pretty slowly just to kind of show you what the process is, and then I'm going to do the next few more or less pretty quickly. So make sure you put each one of the valued parts in parentheses. At the top is going to give you 1 minus 9. The bottom is going to give you 1 plus 1 minus 6. That's going to give you negative 8 over negative 4, which gives you positive 2. So that's plugging in 1. I'm going to plug in 3 now. So I'm going to do this a little quicker. 3 squared minus 9, so that's 9 minus 9, over 3 squared, which is 9, plus 3 minus 6. That gives you 0 over 6 minus 6, which gives you 0 over 0. That is undefined. Because anytime you have a 0 on the bottom, that part here is super important. It is undefined. So I'm running out of room a little bit, so I'm going to do this next one a little bit quicker. So we have 5 squared, which is 25, minus 9, which is 16. 25 plus 5 is 30. 30 minus 6 gives you 24. And reduce it. So I get 8. It goes into both of them. We got 2 over 3. And you're done. Okay, so the next one is a little bit easier. So if I plug in 1, I get 1 minus 3 over 1 minus 2. That gives me negative 2 over negative 1, which gives you positive 2. And that's done. The next one, if I plug in 3, I'm going to do this a little quicker. I get 0 over 1, which is 0. It's not undefined, again, because you have a 0 on top, and that's okay. So it's just 0 as your answer. Plugging in 5, I get 5 minus 3, which is 2, and 5 minus 2, which is 3. So you get 2/3 done. So all that is just practice in plugging in variables values for x, and like that. So, all right. So here is a fact: you can only cancel if there's a common factor in both the numerator and the denominator. The way I think of this as is you have to think of these as like a married couple. So you have the x minus 3 is a married couple. You have the x plus 4 is a married couple. X plus 4 on the bottom is a married couple. And the x minus 5 on the bottom is a married couple. Think of this as like 2 times 3 over 3 times 5. What would happen here is that the 3's would cancel out and you'd be left with 2 over 5. Well, the same thing happens in algebra, whereas if you see the exact same married couple on the top and the bottom, those actually end up canceling out completely. So you can put x through it, slash through it, and then you're left with the other two, in this case, binomial parts. You can put them in parentheses or without parentheses. It does not matter. All right, so what it's going to ask you to do is to simplify. And it also says in your notes to state any extraneous or any restrictions, it should say, on the variable. So I'm going to actually do that first when I say state any restrictions on the variables. So when I state the restrictions are when the bottom is equal to 0. So I'm going to say x squared minus 4 equals 0. I add 4 to both sides. I get x squared equals 4. Square root of both sides, because it's the square root, you have a x equals plus or minus 2 as your answer. The other way of doing it, which will give you the exact same thing, is to use factoring. This is a difference of squares. You get x plus 2, x minus 2, and that equals 0. You set each one of these equal to 0, you get x equals negative 2, and x equals positive 2. You still get the exact same thing for your restrictions. So now that you have your restrictions, we call those restrictions. Those are what x values cannot equal. So they cannot equal positive 2 and negative 2. And that will become more evident in higher level mathematics, namely pre-calculus, and in parts of Algebra 2, but later on. But here, now what we're going to do is we're going to kind of treat these as two separate problems. For example, in Algebra 1, you were given this problem and asked to factor it. So I'm going to do that. So two numbers that multiply to give you negative 12 and add to give you positive or negative 4 is going to be x minus 6 and x plus 2. And now you have your other separate problem, which is the bottom. That is a difference of squares. So the bottom part here is going to factor into x plus 2, x minus 2. So now what you do after you have factored everything, you're going to look for those married couples. So married couple number 1 that cancels out is the x plus 2. Everything else, not so much. So we have x minus 6 is still married, x minus 2 is still married. The x plus 2 is still married, but they went off to like Bermuda or something, so they're gone. So think of it like that. Okay. So important fact is when you do this, make sure you state your restrictions if it asks for it, and that's again the restrictions are where the bottom of the rational function equals 0. Okay, in the upper right hand corner I have this GCF trinomial factoring difference of squares, difference of sum of cubes, namely SOAP, factor by grouping, synthetic division, calculator table, finding a root using synthetic division. Those are all our factoring techniques from Algebra 1 and from Algebra 2 first semester. They are going to be applicable here. So, okay, so first thing it says, again, state any restrictions on the variable. So what I'm going to do is I'm going to take the bottom and set it equal to 0. So this is my restrictions. So that equals 0. I'm going to add x to both sides. I could subtract 2 and then divide by negative 1, but that basically is taking 2 steps. I just took 1 step, so x equals 2 is my restriction. What that means, again, is if you plug in 2 in for x, that gives you a 0 on the bottom, which is undefined, so we call those restrictions. You could also say that 2 cannot equal x cannot equal 2. So, all right, now that we have that, we have to do our separate factoring problem. So I'm going to do the top. So x squared plus x minus 6, that factors into x plus 3 and x minus 2. The bottom one, this is a tricky one, but there's something that you're going to run into quite often, so please pay attention to this. But notice that you have 2 minus x. It's a married couple. If you wrote 2 minus x down here, you would look and say, nothing cancels. Well, here's a mathematical trick for you. Anytime you see the exact opposite, and when I say the exact opposite, notice that the 2 is a negative 2 here. The negative x is a positive x. They are exact opposite signs. So if that's the case, what I'm going to do is I'm going to factor out a negative 1. And what that's going to do to this particular part is going to change the x to a positive and 2 to a negative. And if you want to prove that, you distribute, you get negative x plus 2. It's the exact same thing as up here. So it's a factoring technique that is used, and it's called factoring out the negative 1. So if I do that, now what happens is I have a married couple of x minus 2 canceling out with a married couple of x minus 2. So now I have a negative 1 and an x plus 3. That's one acceptable answer. I would also accept negative x minus 3. Okay, so this trick of factoring out a negative 1 when you see the opposite or the x is negative in a binomial, that's 2 parts, you're going to see that quite often, so make sure you note that in your notes. Okay, next order of business, restrictions on this. We have an x to the third plus 27. This is a difference of or sum of cubes. So this, in terms of restrictions, I'm going to go through difference or sum of cubes pretty quickly. We have x plus x to the third plus 3 to the third. And you want to set that equal to 0. So we have x plus 3, x squared plus 6x, because you multiply these two parts, and then you take the last part, the 3, squared, which is 9. So that equals 0. Now, if you look at this, you're probably looking at this part right here and saying, oh man, I have to actually use the quadratic formula. No. The reason is because your restrictions are not going to be complex numbers. So this part of the SOAP is always a complex number. So the only part that you have to set equal to 0 is this part right here. You have to set the x plus 3 equal to 0. So that means if you plug this in and you get x equals negative 3, that's your restriction. So restriction. And what that again means is that if I plug in -3 into this equation, I will get a 0 on the bottom, which is bad. That's undefined. But again, we're not going to be dealing with complex number restrictions, so you only need to find the real restrictions. But after you do that, then you can factor the top and the bottom. So I have this top part here, which is a factor by grouping. So what I'm going to do is I'm going to factor by grouping here, and factor by grouping, remember, it has 4 terms. So I have my factor by grouping. I have my x squared that I factor out in the first two, which gives me x plus 3. I have my 2 that factors out of the second 2, which gives me an x plus 3. And remember, in factor by grouping, you have to have the exact same thing that they have. I'm going to factor that out, so I get an x plus 3, which means the x plus 3 goes away, and I'm left with an x squared, and then a plus 2. This is all first semester. And the nice thing about doing the restrictions is I also found out what the factored part of that bottom part is. So we know it's x plus 3, parenthesis, and then we have the x squared plus 6x plus 9. So in this regard, what we have is we have the married couples that we're looking for. The only married couple we have is the x plus 3 and the x plus 3. So what that means is those cancel out. Your answer, when you guys get this, again, the answers can be a little tricky because you've got a lot of stuff that's going on here. But the answer to this is going to be whatever your canceled out married couple part is. So we have x squared plus 2 over x squared plus 6x plus 9. Now a common mistake, that is your answer, you're done. Common mistake is people go like, oh, x squared and x squared, they cancel out. 2 goes into 6 3 times. And if you start doing that, what you're basically doing is breaking the rule of marriage in Algebra 2. Because x squared is not married to something that is exactly the same as the x squared marriage down here, so you cannot cancel them out. So your final answer is this, your restriction is this, and you're done. Okay, so this one is, we're going to kind of do the exact same thing bottom in terms of finding restrictions. So I'm going to do restrictions for the bottom is where 2x squared minus 2x equals 0. So we have 2x, I factor this out, I'm left with a x, and then I'm also left with nothing here, which evaluates to 1. So you've got to remember that from first semester. And you set each one of them equal to 0. And we get x equals 0 and x equals 1. Those are your restrictions. That means it cannot equal those numbers. You can also put it like this if you want to. X cannot equal 0, x cannot equal 1. But after you find the restrictions, now we're going to do the factoring. The nice thing is the bottom part here is already factored for you because of the things that you did with the restrictions. So we got 2x times x minus 1. And then the top part, what I see is we have a GCF of 2 and x. So if I factor that out, I get a 2x squared minus 1x minus 1. And then I have to factor that part, see if that part factors. So we have 2x. And this part here will factor. It's 2x plus 1 and x minus 1. Outer part gives you negative 2x. Inner part gives you positive x, which adds to give you the negative x here. That's what you want. So that's your kind of check. And then the bottom part stays the same as 2x and then x minus 1. So now we're looking for some married couples. So we got a married couple of 2x, cancels out with 2x. A married couple of x minus 1 cancels out with x minus 1, and we are left with a 2x plus 1, and that is it, what this simplifies down to. We're going to be multiplying these things and canceling things out just like you would. And the main thing is with this, remember cross-canceling is also going to be applicable, so you kind of treat these as separate entities. You kind of look at 5, 2, 3, and 1. We don't really have anything that cancels out. So I look at x squared and x to the third. I see that 2x's cancel out from here. You're left with x to the first. I also see that the x's cancel out completely here. I have 2y's that cancel out from here. That gives you 1. And then you're basically done. You're left with 10 over 3y. If you're looking at what I just did and you're like, whoa, that was too fast or too complicated, fine, do it this way. This is another way. and multiply the tops. This will be a longer way. So, and sometimes can be harder if you do it this way. So we have x to the third when you add the exponents, y squared. And on the bottom, you have 3, x to the third, because I'm putting it in order, y to the third. Then simplify. The 10 over 3 does not simplify, so we got nothing here. I'm crossing that off just to make sure that I know I did it. The x to the thirds go away. You're left with nothing. The y to the squareds, y to the third, the bigger number occurs in the bottom, so I do 3 minus 2, which is 1 on the bottom. I'm done with those. I still get the exact same thing. But the moral of the story is the cross-canceling is what you're going to start to want to try. Okay, so let's do the cross-canceling with this. And I always want to do the numbers first. So I'm going to do the 8, 15, 3, and 24. I see that 8 and 24 are both divisible by 8. So that means that goes away to 1, that goes away to 3. The 15 and 3 are both divisible by 3, so you can divide those by 3, which gives you a 1 here and a 5 here. And what I do is once I have that, I say, okay, I've got 1 times 5, which is 5, and I've got a 1 times 3, which is 3 on the bottom. Now I'm done with the numbers. Now I have to deal with the exponents. I'm going to do the cross-cancel way, because again, this is a cross-cancel way you want to start to get. I have 3 x's up here that cancel out with 3 x's down here. I have 3 x's down here that cancel out with 3 x's up here, which means I'm left with just an x at the end of it. This one's a little bit tricky. Remember, with this, you can do the top bunk, bottom bunk rule and bring this down to the bottom here. And then you add these exponents, you get y to the 5th. Anytime you have a negative exponent, you want to bring it down to the bottom or to the top, depending on where it's at. But notice I am doing significantly quicker than what I did in first semester, because this is something I'm expecting you guys to know how to do with a little bit of practice. Okay, so now we're going to get back into multiplying these polynomials, which are a little bit more complicated. But the way you want to do these when these get more complicated like this is you want to just treat these as 4 separate problems right off the bat. So I have 1, 2, let's go with green, 3, and let's go with gray is 4. And literally treat those as separate problems. So what I'm going to do is I'm going to simplify the top. I see that I have a GCF. Okay. So the bottom part here is x, let's go with plus 3, and x minus 1. The green part here is x plus 3, and x minus 2. Again, all I'm doing is I'm just factoring these different parts. And last but certainly not least, the gray does not have any factoring that you can do, so you just say 4x. Done. So now, part of the fun, I guess fun if you want to call it fun, so is the canceling. So look for the married couples. I got 4x is married with 4x, x plus 3 is married with x plus 3, and if you are one of those ones that's like, you know what, I'm done, and x minus 2 over x minus 1, you will get this wrong. And here is why. Here is that creep up again. We have kind of the awkward married couple. So this guy is a little out of sorts, so what you want to do is you want to factor out a -1 to make him back in play with the other married couple. So we have x minus 1. It just changes the signs of each one of those when you factor out a -1. You get x minus 2, and then the x minus 1 on the bottom. And these guys go away, the married couples go away, and then you're left with the -1 and the x minus 2. And that can be construed as -1, x minus 2. But you can simplify that into -x plus 2, and that's done. Okay, so here we go again. And notice again that I'm leaving the factoring part up here, just so you guys can look and see that I'm kind of touching upon a lot of these things. So again, treat these like 3 separate problems in this case. Notice I put a 1 on the bottom here. So the x plus 3, can't really do much with him, so he just kind of stays the same. That x to the third minus 1 right here is a SOAP. So you have to do this, and my SOAP here is 2x minus 1. and then I have a 4x squared, 2x, and a 1. And remember with SOAP, its signs are the same, opposite, always positive. And then we have this part here, which is, let's do this in red, so this part here, which can factor as well. And we have a 2x minus 1 and a 2x minus 1 in terms of that trinomial factoring. So once you do this, and again you check to make sure that all the trinomials are factored properly, now you look for married couples. So we only have one married couple here. That's one married couple with that married couple. And what that means is that you're left with an x plus 3, a 2x minus 1, and then this ugliness down here, which is 4x squared plus 2x plus 1. If you want to put that in parentheses, that's fine. If you want to leave it without parentheses on the bottom, that's fine. But these guys up here 100% need parentheses. Okay, so don't forget those. But that is your final answer. Okay, so next one, multiplying yet again, and again we have 4 separate problems. So I'm not going to use my color coding. I'm just going to do these a little bit quicker. So we have this guy here has a GCF of 2, which gives you x minus 4 on the top. This guy here is a difference of squares. So notice I've got a GCF, I've got a difference of squares that I'm about to use, x minus 4, x plus 4. I have a trinomial factoring. So I have an x plus 4 and an x plus 1. And I have another trinomial factoring. If you want to keep track of this, that's 2 trinomial factorings. So you have x plus 4 and x plus 4. Once you factor all of these, now you look for your married couples. We've got a married couple here. We have a married couple here. And it looks like that's the only married couple set that we have. So, how this goes is we have the 2 and the x plus 1 on top. And on the bottom, you can write this a couple different ways. You can have x plus 4 squared. If you don't like that and that confuses you, that's a little bit nicer to do than this, x plus 4 times x plus 4. It's either or, does not matter. But make sure those binomials are in parentheses. That is a very important thing. Okay, so now we're going to get into division. So division is one of those things that is just like multiplication, but you want to make sure when you guys do this in terms of division, this part here is what's going to change everything. So we have 36, x to the 4th, y, that stays the same, as 35, x squared, y to the 3rd stays the same. But this division, you change it, and then you flip it. So it's you keep, you change, you flip. If you guys remember that from middle school. It's with dividing fractions. So in this case we have 20, y to the negative 4. Yes, that negative 4 still stays negative. You'll see why in a second, what we'll have to do with it. The 27 comes on the bottom, negative 3. So we literally just flipped the one that we are dividing by. Now because we have negative exponents in that particular part, what we will have to do is we will have to pull that to the bottom and change locations of that. You'll see what I mean in a few seconds. So this will be 36 x to the 4th, y over 35 x to the squared, y to the 3rd, times the 20 stays the same and the 27 stays the same. But the x to the negative 3 has to become positive, so you have to do a top bunk, bottom bunk rule with him, and with the x or y to the negative 4. So these two parts have to be changed. And you don't want to change them here. You can if you wanted to, but again, that might confuse you because you flipped it. And that's not flipping for division. That's flipping for top bunk, bottom bunk. So it's for a different rule. But now what we're going to do is we're going to do our cross cancel. So I notice that 36 and 27 are both divisible by 9. So I get 4 and I get 3. I also notice that 35 and 20 are both divisible by 5, so I get 7, and I get 4. So since the numbers are done, I get 4 times 4, which is 16. I get 7 times 3, which is 21. So now I'm going to do the variables, and there's a bunch of different ways you can do the variables. So I see that I have 2 that cancel out from the bottom here, so I'm left with a squared. And then I have x to the squared, x to the third, that becomes x to the fifth on top. So now my x's are done. So I like to cross them out just so I know I've dealt with them. I have a y to the first on top. I'm going to cancel 1 out on the bottom here, but I have a y squared and a y to the fourth on the bottom, which means I have a y to the sixth total, which means that cancels or simplifies to 16x to the fifth, 21y to the sixth, and that is your finished final answer. All right, so how does this get a little bit harder? Honestly, I think those previous ones are the ones that are a little more difficult than these, just because I like trinomials, but that's just because I'm a little odd like that. So what you're going to do here is, again, treat these like separate problems, but again, what you want to do is you want to make sure that if you have a division, first and foremost, flip it. And the main reason you want to do that is because you don't want to start factoring and then forget to flip. Because if you do that, like I said, you're going to get a lot of these incorrect. So flip it first and then factor it. So we have the top part here. What he factors into is 3x minus 1 and 2x plus 3. And again, if you want to check, you can always do the outer part and the inner part. Just check and make sure that the upside down telephone or the half moon, whatever you want to think of it as, matches up. So we got a 6x squared. We have times 1 over, and I have a GCF here. Again, I've let that list of factoring techniques on top for you guys. So I'm going to factor out an x. I have a GCF, and I'm left with a 2x and a plus 3. So now that I have my binomials, my GCFs, my trinomials factored, now I look for married couples. So I have a married couple of 2x, goes away with 2x plus 3. So that is basically the only thing that simplifies from top to bottom in terms of canceling out. But don't forget your Algebra 1 rules. If I have the same in line, so left to right, what do I do with those exponents? I have to add them. So I have a 3x minus 1 on the top. Might be smart to put it in parentheses. I have a 6, and then I have a x to the third, because 1 plus 2 gives you 3, and that's done. Finished. All right, so now we have, I'm going to go through this one a little bit quicker because, again, the division and the multiplication are things that I'm expecting to go pretty quickly once you remember how to factor. So look at this guy right here. Remember, he is the reverse odd couple out. So what you want to do is take out a negative from him. And we have x minus 5. And we have the over 4x. And I just said that I would, I told you to divide and do the multiplication first and flip first before you factored. But since I'm actually pretty decent at these, I'm going to start doing 2 steps in one. So what I did is I flipped this, and then I'm factoring it at the same time. You only want to do this if you're actually getting pretty decent at these factoring parts and multiplication parts. So I have the bottom part here, x minus 2. And x minus 5. So my trinomial was factored. I flipped the fraction, and now I get to start canceling. So remember, you're looking at these guys here. They're a married couple, they cancel out. These guys here, they're a married couple, they cancel out. This x here is a married couple with this. And all I'm left with, this is a fancy way of putting negative 1 over 4. This whole entire thing just simplifies to negative 1 over 4, which is pretty wild. All right, so I'm going to follow my rule yet again that I told you to do. So we have 3x minus 12 times, and I'm going to flip. We got x squared minus 6x plus 8 over x squared minus 2x, and then you can start factoring. Again, if you start getting good at these, you can start to kind of do 2 things at once, but you don't want to start doing that too early on, or else you're going to probably confuse yourself. So the top trinomial factoring part here is x minus 4 and x minus 2. On the bottom part here, we have a GCF, x minus 2. So notice we had 2 GCFs and a trinomial, and now we're looking for married couples. We got a married couple here. We have a married couple here, so now x's cancel out, so I'm left with a 5 over 3. All right, so how does this get a little bit harder? Well, instead of having 2, now you have 3 parts, which means you have 2 different techniques in one. So the first thing you want to do is write everything like you would. This is over 1, so we got 3x minus 5. That's over 1. This is a division, so you want to change that to multiplication by flipping it. And this is 9x squared plus, or minus the 25. So here, now you can start factoring. I'm going to be super lazy and say that this part here is the exact same, so I'm just going to copy and paste him. Took me like 20 minutes to do that, that's okay. And this part here, I'm going to factor. We have x plus 5. And again, if you want to put these in parentheses, it will definitely help you. We have a difference of squares here. It's 3x minus 5, 3x plus 5. And what that means is now you're looking for married couples. So we got a married couple that cancels out with here. We have a married couple that cancels out here. And we are left with an x over 3x plus 5. And that is done. Okay, next one. So this is just basically practice. So again, I've got my 3 parts here. So I'm going to put this over 1. I'm going to do a little bit quicker. Like I said, I'm going to start factoring this as we go. So x plus 6, x minus 5 over 1 times. I'm flipping this. So that means this is going to be x plus 3 and x plus 4 on the top. And the bottom part is going to be this part here. So we have x minus 5 and x plus 3. And then we have times. There's that opposite one again, the oddball couple, which you want to make sure you factor out a -1. And we have x minus 5. And then we have the x plus 6, which is a binomial. I would put them in parentheses. So now you got your married couples that cancel out and get to go on vacation. So we got the x plus 6s, they get to go, yay for them. We have the x minus 5s, they get to go, yay for them. We have the x plus 3s, they get to go. And all you're left with is a wonderful -1 x minus 5 times x plus 4. And I'll be honest with you, you can just keep it like that. If you wanted to FOIL it out and distribute the -1 to get a trinomial, that's fine as well, but this is also acceptable. All right, a couple more. So we have the top part here, we got x plus 7, x minus 1. We have the 3x squared. He doesn't change. We have the 6x. We have the x plus 7. I'm going to put him in parentheses. He doesn't change. This guy here, because of the division sign, we put the top 4, the bottom x minus 1. And now I have everything ready to go for canceling. So we cancel out this with this. We cancel out 1x here. We cancel out a 3. Goes into 6 twice. And we have another x minus 1, and I should put parentheses around here, another x minus 1. And we are left with 2 times 4, which is 8, over x. So that whole thing reduces down to 8 over x. Done. All right, last but certainly not least, if you want to pause the video and try this one on your own, I'm just going to post the answer. And here is your answer. And that is basically it. So, if you have any questions, let me know.